Hello, we are software engineering researchers from UC Irvine, Nanjing University, and Rochester Institute of Technology. This video briefly introduces our latest study on a special group of open source software developers. Currently, open source software and its community are critical infrastructure of the software engineering practices. Their communities are formed from a loose collection of individuals with various contribution activities. These contributors and developers perform wide-ranging software engineering activities. Their activities establish complex role-based relationship between them, while the role of a developer in the community may also shape her activities and workload. Among OSS contributors, there is a small admin group, the elite developers. Their administrative privileges enable them to maintain a diverse portfolio of contributing activities. Their activities substantially drive the success of the open source community. To further understand and support this group of developers, we propose 3 research questions in this study. First, what do elite developers do in addition to contributing typical technical code in open source software projects? Second, how does the open source software project's elite developers' effort distribution evolve along with the growth of the project? Finally, what is the relationship between an open source software project's elite developers' effort distribution and the project productivity and quality outcomes? We sample 20 large-scale open source projects hosted on GitHub and conduct a longitudinal observation on their developers' holistic activities. While selecting the projects, we ensure each project has established administrative structure. The project should contain traceable records of continuous contribution from year 2016 to 2018. We also include various application domains and find that there are 11 projects with industrial company sponsorship in our sample. After we decide the target project set, we collect the activity and project outcome data from 2 major data sources. First, JH Archive, a public event data dump which records most activity events appear on the GitHub's event data timeline. Second, the GitHub REST API, which provides issue and commit events as well as the project outcome statistics. Finally, we collect 900,862 events from 20 projects. However, there are over 30 types of collectible GitHub events. Most of them are very atomic and difficult to understand or to indicate the trend of efforts. We employ a well-established system of 4 major activity categories from a pilot organizational behavioral study and redefine the categories under the context of software development in GitHub environment. Categories are communicative, using commenting feature in the GitHub environment, organizational, administrative activities such as assigning and other member management activities, supportive, non-technical activities while applying the GitHub collaboration environment, and finally, typical activity, the typical software development activities such as committing source code. As we define 4 categories of activities, we mapped our type of atomic activities onto these 4 categories through our closed card sorting activities. 3 researchers independently mapped these events into the categories and reached a substantial agreement as 0.77 kappa. All conflicts were resolved in a final discussion. The event mapping result displayed on the right. In addition, we employed 4 well-established indicators for measuring project outcomes for from prior software engineering literature. For indicating the productivity of a project, we use the number of a project's new commits in a project month and the bug cycle time, the average cycle time of a project to close the bugs in a project month. Further, for indicating quality, we apply new bugs, the number of bugs found during a project month, and bug fix rate, the ratio of fixed bug among all found bugs. After the preparation work done, we carefully picked the analysis method for each research question. For the first RQ, which investigates the activity profile of elite developers, we simply employ the descriptive statistics. For the second research question, investigating the effort distribution evolved along with the growth of the project, we apply the descriptive statistics for computing the growth rate for each category of activity, and conduct one-way ANOVA to test the differences between activity categories. For the last research question, testing the relationship between effort distribution and project outcomes, we employ an advanced econometric method, the fixed effects panel regression, to test whether such relationship exists. Let's briefly go over the result for each RQ. For the first RQ, we empirically confirm that elite developers perform wide-ranging activities. They perform substantial amount of contribution activities in the community. Particularly, they perform over 60% of the supportive and typical activities, and also perform over 34% of communicative activities. We find that compared to an ordinary non-elite developers, the elite developers groups are very active in average. They delegate tasks among the development team, they manage parallel development, they create documentation for the project, and they still participating in various online discussions. For the second research question, to identify the trend of efforts in various categories of activities, we compute the growth rate of each activities and conduct one-way ANOVA test on the growth rate. The test results suggest a significant differences between activity categories. Thus, we further conduct the post hoc two-course HSD test and find that the growth rate of typical activity is significantly different from and actually lower than the communicative and supportive activities. To answer the second research question, we find that elite developer groups tend to put more effort into communicative and supportive activities as the project grows, while reducing their involvement in typical development activities. For the last research question, we test the relationship between effort distribution and project outcomes. We conduct the panel regression on the three samples, whole, company-sponsored, and non-sponsored. We respectively test the relationship between effort distribution with the productivity and quality indicators. Finally, we conduct the time-related effect analysis to test the elite developers' impact on the project as the time goes. For productivity indicators, efforts on communicative and supportive activities are negatively associated with the number of new commits. Efforts on organizational activities are negatively associated with bug cycle time, while unsupportive activities are positive. For quality indicators, efforts on organizational and supportive activities are positively associated with the number of new bugs. Efforts on communicative are negatively correlated with bug fix rate, while unsupportive are positive. In summary, non-coding activities are negatively associated with project outcomes. Three samples are showing similar effects, but the company-sponsored samples show stronger association. Further, we conduct time-related effect analysis to test the relationship between the elite developers' impact on the project and time. We find that in later stages of the project, new commits and bugs are less associated with lead developers' activity, but there are no significant effects for bug cycle time or bug fix rate. In summary, efforts on non-typical activities are negatively associated with project productivity and quality outcomes. The effort distribution of the elites in company-sponsored projects have a more significant relationship with these outcomes. And finally, the effect analysis suggests that with the project growth, the elites have less impact on project's technical outcomes. This study empirically confirmed empirical research on OSS community. We find that the developer community is still largely driven by the elite developers, while the substantial contribution from elite developers ensuring the bottom line outcome of the project. We still need to carefully watch for the long-term health of the project. We find that imbalanced workload in the community is not only on technical contributions, but on all types of activities. Further, we identify a role transition of elite developers in the open source community. We find that they start the project as co-contributors and gradually move to management positions. As prior organizational science literature suggests, such a transition is very risky to individuals and also to the organizations without proper training. Finally, we identify a dilemma for elite developers to face as project grows. They often need to deliberate their efforts between technical and non-technical activities. This study provides implication for both practitioners and researchers. For practical implication, we suggest the current open source project may decentralize the central authority, especially for some basic routine administrative activities and such as managing issue repository. In addition, we find that Patrick Wexstrom's recommendation, which suggests only communicating when meeting individual coordination requirements, still applies to open source project. For design implication, we suggest that we may apply automation techniques for assisting elite developers' routine supportive tasks and support the necessary communication with the non-elites. To sum up the contribution of this study, it is a study categorizing elite developers' activities and their dynamics, and also identifies the relationship between their activities and the project outcomes. We provide a set of recommendations for both practitioners and researchers. We take a fresh perspective on investigating activities of OSS developers. And finally, we prepared a well-cleaned data set comprising all event data from a set of large open source projects. This is about the end of the presentation, and thank you for your attention. You can address this paper from the references below for further details.